Okay, so let this one is the center of the electron cloud, and the positive charge might be slightly towards right. So on the application of this electric field, the presence of the electric field, so there will be slight deformation on the electron cloud, and there will be a small charge separation between the electron cloud and positive charge nucleus. And let the charge separation I will denote by symbol D. So this is the effect. So the application of electric field will separate the charges by a small amount. Okay, so recall the amount of charge in the nucleus and the amount of charge in the electron cloud are same. So there is an equal and opposite charges separated by some distance d. So there is some specific name for it. So if an equal amount of charges with the opposite polarity are separated by a small distance, they are called as physical dipole. Okay, so if you consider a negative charge, okay, yeah, I can just write here. So a physical dipole. So an equal amount of negative charge and positive charge separated by some distance d. Suppose this vector is vector d. Then I can define dipole moment p, which is equal to q into d. So this p is called dipole moment. So this definition you might have studied in your higher secondary itself. So equal amount of opposite charges separated by some distance d, then we can define dipole moment of that physical dipole as vector p equal to q into vector d, where vector d is a vector connecting the negative and positive charges. So here the same thing happens here. We can see a charge separation within the neutral atom. Okay, so this charge separation is also called the production of a dipole. So a dipole moment or a dipole will be induced inside the atom if you apply the external electric field. Okay, so an induced dipole moment is being produced here. So this induced dipole moment I can write as vector p. And this induced dipole moment in general would be proportional to the strength of the electric field. If the electric field has a very moderate strength, if the electric field strength is very large, then the p need not be proportional to E. There can be some other effects as well, because these charges may well get separated, and so ionization may happen. So many things may happen if you apply very large electric field. But if the strength of the electric field is moderate, so if the strength of electric field is moderate, then the induced dipole moment would be proportional to the applied electric field, and I can write as an equation by introducing a proportionality constant, and proportionality constant is noted as alpha. So P I can write alpha times E, and this alpha is a scalar, and this alpha is called atomic polarizability, and that would be characteristic of an atom. So the value of alpha may change with atom. Atomic polarizability. So for hydrogen, the alpha have some value. For oxygen, it will have some other value. Okay, so this is the effect of the electric field on a neutral atom. It will induce a dipole moment, and the direction of dipole moment will be along the direction of the applied electric field, and this alpha is simply a scalar quantity. Alpha is just a number. Now, what would be the effect of electric field on a molecule? So molecule, there are two types of molecule: the molecule with non dipole moment and the molecule with inbuilt dipole moment. So effect of electric field on molecule. So the electric field that we are discussing is the static electric field. So the first part of discussion is a molecule without inbuilt dipole moment. So if you look at carbon dioxide, the better example is the carbon dioxide. So there is two oxygen and one carbon. Oxygen will be negative and the carbon would be positive. So oxygen, oxygen, carbon. Okay, so here the atom, this molecule will not have any inbuilt dipole moment. Okay, now if you apply some electric field here, if we apply some electric field, suppose along this direction, what would happen? Okay, so why we say that there is no inbuilt dipole moment? Because if you look at this, there is a two charge separation, negative to positive this direction. So here and dipole moment is towards right, and here the dipole moment is towards left, and that will cancel each other, and then a net dipole moment is 0. Remember, dipole moment is a vector quantity, so net dipole moment is 0, so opposite dipole moment will cancel. Okay, now here suppose if you apply the electric field in some direction, now this electric field I can resolve into two: the electric field parallel to the direction of bond and perpendicular to the direction of bond. So this electric field parallel to the bond and electric field perpendicular to the bond. Okay, now the effect of electric field parallel to the direction of bond and perpendicular to the bond may not be same. So the parallel electric field will produce some dipole moment P parallel, and that I can write as some alpha parallel E parallel. And the electric field perpendicular direction of bond will produce some other dipole moment. I can write P perpendicular, that can be equal to alpha perpendicular E perpendicular. Now in general, this alpha parallel is not equal to alpha perpendicular. Okay, so what is the net effect? So the net effect is if the total dipole moment produced is P on the application of the electric field E, then P I can write as some alpha parallel E parallel plus alpha perpendicular E perpendicular. So the effect of electric field parallel to the bond and perpendicular to the bond are not same. Okay, so therefore in general P and E need not be parallel. So that means the induced dipole moment, may not be along the same direction of the applied electric field. It may have along different direction. because these alpha parallel and alpha perpendicular are not same. Then the induced dipole moment and the applied electric field may be aligned along different directions. So remember, the applied electric field is a cause and induced dipole moment is the effect. So the cause and effect may align along different directions. So such things are not there in case of neutral atom. If you apply the electric field for the neutral atom, the direction of the dipole moment, the induced dipole moment, is along the same direction of the applied electric field. But in case of a molecule in general, the direction of the induced dipole moment may not align the direction of the applied electric field. So therefore, the equation connecting, so if this cause-effect relation are not along the same direction, then the equation connecting the cause and effect must be a tensor equation. Okay, so how to write this equation in general? So this equation I cannot write as simply P equal to alpha E, where alpha is a scalar. That is not correct. I cannot write in this way. So how I can write? So I can write in a matrix form. So I can write this equation as Px, Py, Pz, which is a column matrix, equal to some square matrix times Ex, Ey, Ez. So this alpha contains, so this would be a square matrix that will contain total of 9 components: alpha xx, xy, xz, alpha yx, yy, yz, zx, zy, zz. So this is the general expression for the relation connecting the induced dipole moment and the electric field. So the quantity which comes here is not a scalar, it is a tensor, and this tensor is called polarizability tensor. So remember, so now I can write P equal to alpha times E. Here alpha is not a scalar, it is a polarizability tensor. Okay, now the value of the components, the 9 components of alpha, depending upon the molecule. For different molecules, this value would differ. Okay, and if off diagonal elements are 0, for some molecule it may happen that all off diagonal elements are 0 and only diagonal elements are non-zero, then the direction of P and direction of E would be the same. So that is the one way of looking at it. Okay, and but in general, the direction of the dipole moment and the electric field are not same. So this is the effect of the static electric field on uh, the molecule without any net dipole moment. Okay, so if a molecule have a net dipole moment, then what would happen? So I think that I will discuss in the next session. Okay, so before that, I will just summarize what are the things we have discussed till now. So electrostatics in matter is basically a discussion of the static electric field on insulator. And insulator contains microscopically insulator contain very large number of neutral atom or a neutral molecule. So in order to understand the effect of electrostatics or the effect of electric field on insulator, we should actually know what is the effect of electric field on atom and as well as the effect of electric field on molecule. Now if you look at atom, the effect of electric field is just production of induced dipole moment, and for moderate electric field, this induced dipole moment can be written as some alpha times E, where alpha is a scalar and this alpha is called the atomic polarizability. Okay, and finally we have discussed the effect of a molecule, the effect of electric field on molecule without any inbuilt dipole moment, and example that I have taken is the carbon dioxide. So if you take any molecule without any dipole moment, then what may happen that the direction of the induced dipole moment may not be along the same direction of the applied electric field, so it may differ. because the polarizability alpha may change with the direction. So the effect of the electric field parallel to the direction of bond may not be same as the effect of electric field perpendicular to the bond. So this is the direction of bond here. So the bond is along this direction. So if you apply the electric field along this direction, the effect would differ than the application of electric field perpendicular to the bond. So in general, the P and P and E may not be along the same direction. So hence, I have to I have to connect the applied electric field and induced dipole moment as a tensor equation, and uh, the proportionality constant which connect the electric field and P would become a tensor, would become a matrix, and that would become a tensor. Okay, so it is a second rank tensor, and it will have a total of 9 components, and they are called the polarizability tensor. And the polarizability tensor, the value of the components of the polarizability tensor is depending upon the molecules. Okay, so it is the characteristic of molecule. Okay, so in the next class, what I will discuss is we'll discuss the effect of electric field on molecule with inbuilt dipole moment. Okay, so let us stop it here. So we'll start our next session on this topic. Thank you.